We're with Ichiro Sugioka. He's Volvo's recharge concept car. And Ichiro, you're going to tell us about this car and how soon it will be on the market.
Oh, well, first thing, I should tell you a little bit of history behind this car. And I work at the Volvo Monitoring Concept Center, which is a think tank in Camarillo, California. And we've been looking at a wheel motor type of hybrids since 1990. Back when we did the environmental concept car, which was more of a regular type of plug-in hybrid back then, but using a gas turbine engine. We really wanted to use wheel motors in the car, but the technology wasn't ready, and also the battery technology wasn't ready. So
the lithium-ion battery.
Right, lithium-ion. Back then, all we had we didn't even have nickel-metal hydrides back in 1990. We only had nickel-cadmium or lead-acid batteries, and those really didn't have the power or the energy. Now we've gotten to the point where we finally found, well, the battery development with lithium-ion has been very impressive, and so we tested where they are at with the 3cc about 2004, and that was also my project. And then with this car, we are also able to use the wheel motor technology. We've been watching the technology of motors develop, so we finally found the technology that would give us sufficient torque that would still fit inside an 18-inch rim, and that was very important.
so motors, in this case, are just as important as the lithium-ion battery.
Yes, exactly. Yeah, because most of the time until now, the motors had to be sufficient torque, and now we have a new technology that will allow us to get sufficient torque that will fit inside an 18-inch rim. And we also combine that with a new tire technology as well, and it's something we've been working with Michelin Tire Company about. But just to kind of come back, the reason we like wheel motors was that it's something that gives us a higher efficiency because we don't have transmission anymore, and usually the transmissions take energy out when you accelerate, when you're moving the car forward, but also when you're regenerative braking, you lose, throwing away the energy, and that's we're talking about 10 to 15% in both directions that we're recovering into the battery, and so that was important to us as well.
What kind of, on a real world, what kind of miles per gallon would you get on this car?
Well, efficiency-wise, right now we're estimating, because we have not done the full driving cycle test yet, we're getting about 45 miles per gallon just on the engine. Now, if you run it as a plug-in hybrid, and one of the things that's actually lowering that mileage is the fact that we're carrying enough battery to run 60 miles on battery power alone. And that would, if you factor that in, we'll get equivalent to about 100 miles per gallon for the first 100 or so miles. And then that's something that, because you're only using the engine for the last 40 miles, if you're going 100 miles, for example.
So you're plugging this in?
Yes, it's a plug-in hybrid, and by keeping the motor the way it is, we could recharge the motor in about 3 hours out of a standard household outlet.
How long before it goes into production?
Well, that's a good question, because right now the wheel motor technology that we're using just came into being this just past year.
Who made it?
This is a company called PML FlightLink in United Kingdom, and actually we work with them a little bit so that now we've increased the torque on the motors, so they're 1,000 Newton meters per motor. So we have 4,000 Newton meters going to the ground in this car, and that was what was really needed for the braking performance that we needed to get, because we wanted to use as much of the electrical braking instead of frictional braking to recover the energy. And so that technology just is very in its infant stages, and we also have a lot of work to be done in terms of control systems. We could control all four wheels independently. So actually now this greater flexibility and versatility is actually creating more of a control problem than a simple mechanical system would.
How long before production?
Yeah, I wish I could say very soon, but right now I can't say that because we just started to experiment. We have a test vehicle. This is a cutaway model of a test vehicle we have in Sweden that we're actually taking apart more often than running right now.
Who are you testing it with? Is it an electric company that you're working with, or is it...
That's a good question. I'm glad you got to that, because one of the things that we're missing right now in this vehicle is what would be called a smart plug. one of the things we've learned by studying some of the reports on plug-in hybrids in the United States is that it appears that a plug-in hybrid, when it's connected to the grid, becomes part of the grid. So it actually could provide a service to the grid in terms of regulation and also what's called spinning. There's several services that a large battery could provide to the grid, essentially hybridizing the electrical grid.
So it stores the electricity.
It stores electricity, but it also does a little bit more than that. There's just like a voltage regulator would, it helps the grid become more efficient. And that's something that's, I'm not an expert on it, and Volvo is not an expert on it, so we've been talking to people at Pacific Northwest National Labs and also Swedish utilities to get a better understanding of how a car could actually serve the environment, actually serve the society when it's parked. You see, interesting thing is, car is parked about 95% of the time and it doesn't do anything. But with a plug-in hybrid, if it's plugged in, it would be doing a service to society while it's plugged in by actually trying to make the electric utilities more efficient. And the calculations from these utilities is that the service that one car could provide to the utility is worth about $2,000 to $3,000 a year, and that could go a long way toward subsidizing and helping pay for the battery and the motor technology in this car.
Good luck.
Well, thank you.
Thank you very much.
You're welcome.